Hello everyone, good afternoon. Welcome all to the 2025 PacVec Fall Seminar Series. I'm Karthikeyan Chandrasekharan. I'm based at UC Riverside. And today we have two speakers, Dr. Chloe Reyes and Dr. Lara Backus. Sorry, excuse my pronunciation. Uh, and we'll have Chloe go first for the first 30 minutes. So 25 minutes for the presentation and 5 minutes for questions, followed by Dr. Lara Backus for the second 30 minutes. Um, a quick introduction about Dr. Chloe. Dr. Chloe Reyes is an undergraduate psychology major at Arizona State University. In the Embodied Games Lab, she designs and studies interactive learning experiences through the lens of cognitive psychology. After presenting at the PacVec conference on gamified outreach to reduce mosquito breeding sites, she became involved in creating educational games for children that focus on relationship building and collaboration, as well as projects on virtual reality learning and water conservation education. Over to you, Dr. Chloe.
Perfect. Thank you for that introduction. And again, my name is Chloe, and I'm going to go ahead and share my screen here for a bit. You are going to see my dog until I pull up the PowerPoint. Okay, can everybody see the PowerPoint? Good to go? Okay, it's not the presenter view. Okay, awesome.
It's good.
Perfect. Yeah. So again, my name is Chloe. So I work at the Embodied Games Lab where we create STEM education and we focus on the cognitive psychology aspect of it. So learning and memory, like what we're building are people actually learning? So of course, I'm grateful to be here and excited to share a project developed by a multidisciplinary team that compares traditional learning versus gamified outreach methods focus on mosquito breeding site reduction that we did this past year. So, of course, I might be preaching to the choir here, but of course, in the state of Arizona, Maricopa County, home to the Phoenix area, has reported multiple outbreaks of the West Nile virus, including the largest outbreaks in a single county in 2021. So, new cases are still being reported, reminding us that awareness and prevention is an ongoing challenge. Despite public service announcements and educational events, the public health department has reported that people still lack an awareness, even in active outbreaks. So this is where our study comes in, and we want to compare traditional versus gamified outreach to see which is more effective. Not only that, but what if it works differently across different age groups? Prior research has shown that interactive formats can improve engagement, behavioral change, and support meaningful learning. So our research asks, does gamified outreach improve mosquito prevention better than PSAs or web-based informational content? So we used a 2x3x2 mixed design, including both between subjects and within subject comparison. So we studied three factors. And the first factor is going to be delivery format. So or how is the material being delivered? So we have our control group, which is going to be our public service announcements. These are going to be like PDFs. I'll show more slides on our control group. And then we also have our experimental group, which is going to be our epic mosquito game. The second factor is going to be developmental groups. So who is going to be receiving this information? We have seventh graders, which is going to be our junior high, our college students, typically aging around 18 to 25 years old, and then as well as our adults who are specifically screened to be 45 and over, and our homeowners in the state of Arizona. And then our third factor is, of course, going to be the test time. So a test will be given to participants before and after the intervention. So we predict that participants in the experimental game, will show higher learning gains than those in the control group across all developmental stages. But we're especially interested in the 45 plus group because we think that the effect might be mediated by amount of gameplay. In other words, like do these adults that we are putting them in our experiment, do they have prior experience in video games? So going back to our delivery format, this is what our control traditional outreach material looks like. This is just a good half of a sample. It's like a 10-page PDF mixed in with a comic, with like a comic book strip, life on mosquito, a PDF on mosquito life cycle, and as well as like information for the Maricopa County. So the next one is our experimental game is from Epic Mosquito Quest, which is designed to teach the same content, but in an interactive and engaging way. Participants can choose a character, name the character, and start exploring. So here they're coming, this is inside of the house, gathering stuff to clean like the gutters when they go outside, or looking at the pool. So the participant is taken first to the introduction that includes awareness of diseases, mosquito life cycle, and breeding sites before they actually start playing. The participant then can explore in their community. So each breeding site or item will display a question and points are given to the correct answer if selected. If they click on deep dive, they have options to learn more. And then options are available to learn more about mosquitoes and actually show real life examples of breeding sites. Okay, so going on to our factor two, like I mentioned, the developmental group. So who will be receiving this? So we worked with three developmental groups, which were our seventh graders, our college students, and our homeowners. We were able to gather 50 seventh graders and from a local Arizona school, and they did this experiment in a formal learning environment. So we did go during their class time. And then our college students are from Arizona State University, and using the Psychology Sona database, we were able to just retrieve students in our research room and then give them course credit after completing the experiment. We gathered 47, and then as well as our adults, we were able to gather 40. So all of our adults are age 45 and up, and they're screened to be homeowners and residents of Arizona. We gathered all of these experiments by word of mouth. Luckily, I live in a nice, friendly neighborhood, so that was very easy. Our original plan was going through mechanical MTurk, but that was a little bit difficult than it seemed. There was a database that was shared with ASU that we tried to promote our research that didn't seem safe for us and what we were trying to do. So we did it by word of mouth, which explains how we were only able to get 40 and not 50 across the board, across all developmental groups. So like I had mentioned, the factor three is going to be our test time. So all participants complete a knowledge assessment before the intervention and again afterwards. This lets us measure knowledge gains across both the control and the experimental game condition. So the test is invariant. However, at the beginning of the post-test, we do ask a couple of demographic questions. To measure learning, we ask participant multiple choice and scenario-based questions related to mosquito prevention. Our main learning goal is for them to understand is to take care of something that could hold standing water for more than 7 days at least half an inch deep. So what did we collect and what did we see? So the first chart here shows how participants' overall knowledge improved from before to after the intervention. So we saw clear learning gains across the full sample, which means both outreach methods were effective in teaching people how to identify and reduce mosquito breeding sites. So regardless of whether the participants played the game or just read the PDFs, everyone walked away knowing more than what they started. Now going into a little bit deeper, when we break down the data by age, younger participants showed the largest increase in knowledge. But compared to the college students with the junior high and the college, they were just about the same. However, when we look at our adults, our adults showed smaller changes overall. This pattern makes sense. So this pattern makes sense because young learners typically start with less baseline knowledge and they have more room to grow. Still, every group demonstrated positive learning gains, which reinforces that these materials are effective. Now, the real question. So does game versus traditional outreach, does that matter? Is that significant? So for this part of the study, our prediction was that participants in the game condition would show higher learning gains than those in the control across all developmental stages. When we looked at the results, we actually found that both delivery modes improve knowledge and that there wasn't a clear overall advantage for one over the other. What we did see was a trend for interaction, meaning the effect of the game versus the traditional materials varied slightly by age group. So college students showed slightly higher gains in the traditional PDF. Adults showed slightly higher gains in the game condition. And the junior high students learned about the same in both methods. So this kind of opens up discussion for future research. We also want to note that maybe the college students learned more in the control condition because the game that we created is targeted for like originally when we had created the game, it was targeted for middle school audience, a lower age group. So we just saw that maybe when the college students learned in the condition that the game was too kiddish for them, right? So they learned more about reading. So within our test on question number 18, we asked about like behavioral action, essentially like if they were to change anything and what would they do? And we tested that before and after. And so it just asked participants to identify behaviors that reduce mosquito breeding sites by checking all of the boxes. And what this shows us is that everyone across the age groups change their behavior, whether that is identifying the breeding sites or what they would do in that scenario across all of the developmental groups. And we suspected the adults again, you know, it's very close and within the pre and post test because they're more knowledgeable. They already know, well, we would hope that they already know what to do, but they are more knowledgeable in a way that they're homeowners. They've been able to see the mosquitoes in their backyard or experience some type of like interaction with them. Versus like our college students, most of our college students, when we were looking at the demographics, they were living at the dorm rooms or they were away from home. So they necessarily didn't know how to approach these scenarios. But when we did the intervention, we did see, of course, a gain. So they did learn something. So regardless of the condition, this had the greatest impact on younger audience, especially teens and college age participants. So our conclusion and future direction. So of course, overall, both outreach formats were effective in teaching mosquito prevention. Like I had mentioned before, the game seemed to keep younger participants more engaged, while adults already had a stronger baseline knowledge. And in the future, when it comes to creating the game or possibly exploring other like components, I would definitely do more of an embodiment within the games, possibly go to more of like a VR or a phone app. And then also targeting different audience, I would probably make it more sophisticated for an older audience. And of course, thank you all for those. I like to take a moment to acknowledge my PI, Dr. Mine Johnson Glimberg, Dr. Sylvie Hyben, Chuck, and then also my lab partner, Alona Clark.
Okay. Thank you, Chloe. for the wonderful presentation. We have plenty of time for questions. Okay, I'll get started with the first one. Um, so you showed that engagement varies across age groups for your approaches, right? But we also know that the preference for outdoor exposure, if they were to go out and implement some of the learnings they've had from the material that you have provided, either the traditional way or the gamified approach, the preference for outdoor exposure also changes with age. Probably younger age groups would want to be outdoors relatively more compared to the older people. So how do you think that kind of impacts the actual intended outcome, which is to like prevent mosquito-borne disease transmission?
Yeah, so like you had said, the younger group would like to be outside more. And I think, when I had talked about doing like a future direction, we had also talked about making a mosquito game in which we would create a phone app in which little kids would go out and actually be able to look and identify with their phone. And I do believe that, especially with the mosquito outbreaks and the diseases, that we're not going to be able to find a one fits all type of outreach. It's definitely going to have to be divided and conquered, essentially. I hope I answered your question.
Yeah, yeah, yeah. Then on that note, I also have a follow-up question. So when we do pre-test and post-test survey, typically with surveys, I think um, people on the younger side, college students or students typically are forced to answer in a certain way. Like for example, if you ask them, did you learn anything out of this particular exercise? Some of them would be forced to say yes in some ways because they think they have gotten the change or they have been impacted positively by the process or anything. So there could be some kind of a bias from the self that could probably be like getting into those assessments. So is there a way to like kind of see the intended impact of these surveys versus what actually happens with the outcomes as far as vector control or those things are being done? Like, do you see these people actually doing something good in their communities that brings the numbers down for like number of mosquito habitats?
Yeah, so I think I wasn't able to talk more about it, but we're definitely still doing more like statistical analysis on this. This was just mainly the huge bunch of it,
Mhm.
but in the pretest and the post-test, we are actually able to see what they're actually doing. So we don't just it's not like a multiple choice. We give them opportunities to say like what they have done in the past or what they have been doing, and it's actually interesting to see because a lot of it is like family based, like, oh, my mother told me to do this, oh, I heard this, and it's so interesting to hear other stories. But to answer your question, I would it would be nice. It would definitely be nice to see if these people were actually doing it. But we tried our best to see what they had prior to coming in, and if not just oh yeah, I know about mosquitoes. It's like more of like, okay, well, tell me what you know. But we were able to assess that in our pre-test and post-test.
Right. Thank you.
Mhm.
Others, if you have questions, please ask Chloe.
Hi, Chloe. Thank you so much for your presentation. It was really interesting and always love seeing this kind of work. Um, Related to this particular group, it's obviously hard, but is there any thought on like tracking people over a longer time frame? Like, so you've given them this educational opportunity, and can you come back to see them 3 months later or the next year and see what kinds of impact that you've had? Like, do they still remember things? I'd love to see if you've got some plans for that or some different ways that you might try to track that in the future.
Definitely. I there has not been plans yet to track it, but I do see just a little bit of what from what I gathered. Like I said, I live in a really great neighborhood, and I know all the people that were in the homeowners. And it's so funny because I would come over or I would see them on the street while I'm walking my dog, and they were like, they'll be like, watch out for that puddle. That's a mosquito breeding site. And so it's just so funny because it's just now that everybody that I'm around or who I like tested on the game, they always seem to remember this. And whether that would be like the control group or the game, I always get feedback how they just always remember, especially now that it's raining over here in Arizona. I'll still get a few texts from like all my neighbors, and they'll be like, be careful, we don't want to attract mosquitoes or something to that extent. So as far as like future direction, I don't have any plans for that yet, but there is hope that people are learning and retaining this.
Yeah, we have Chris raising his hand. Chris, over
Yeah,
to you.
I was also just wondering about one of the constraints on outreach for traditional methods or gamified methods is always that we have to find the audience and you have to reach the individual people who are the recipients of the information. And it would be really effective if there's ways to get people to propagate that for you. And one example is like Duolingo, which is gamified language learning. And that has a social aspect to it so that you can share it with people. And I know you're not looking for people to have daily material you'd have to produce for that, but I'm just wondering if you see ways forward on incentivizing people to propagate it for you to reach other people.
I don't have any plans for that yet, only because this game we are not necessarily the owners of this game. We co-develop and we were able to add in some extra stuff that we needed for the experiment. But this game is online available to everybody. But as far as like to answer your question, I definitely have to get back to you on that one.
Okay, it could be interesting just to think about generally. Just I know it's hard to make it fun. You have to give really sort of curated, careful public health messaging, which I think limits the ability to make it really dynamic in terms of interaction and answers. But if there was a way to get people to want to share it, that could be interesting. Thank you.
Thank you, Chris. Other questions for Chloe?
I have a quick question.
Yeah.
I was curious what how when you gave people the reading material, sort of what was the con for your control? Like what was the context in which you did that? Like because a lot of times, you hand people reading material or it comes in the mail or whatever and they just toss it. But was it sort of like with the instruction to read it with you standing there kind of thing?
Yes, I would just kind of be off in the background. We did keep the participants separate though. So I would never put two people in a room, one doing the game, one doing the control, just in case they looked over and they're like, "Hey, why are you playing a game?" But I would keep them both. It would just be in a research lab. And then I would tell them that they have a certain time to read it. What was definitely very interesting is that none of them would take the full time I allotted for them. So they just kind of read through as I just kind of stood back. I wasn't like hovering, micromanaging. It was just more of like, okay, here's some material to read. Let me know when you're finished. And I always made sure that I asked, do you want to read it again? Do you have more time? Especially with the college students. And then they were just like, no, we're good. And then it's crazy how they learned more in the condition than they did the game. So it's really interesting. But to answer your question, I just kind of let them be. I gave them instructions and I just was just kind of in the background.
But they didn't have their phones there to distract them.
No.
We have a question from Christian Luna in the message box. Have you considered working with teachers who could have their students take the survey at the beginning and end of the year?
Say that again.
Have you considered working with teachers who could have their students take the survey at the beginning and end of the year? Like school teachers in a classroom context, but trying to engage with school students, like for your surveys.
Oh, for the surveys, like
For the
doing
surveys
it
and the gamified approach as such, like, yeah.
No, definitely. We considered working with like science teachers specifically, and then of course we would conduct the same like pre-test and post-test. But it would just be really interesting, if we prolong that a little bit longer to do like as mentioned to take the survey at the beginning and at the year. We have considered it. Yes, we have.
Wonderful. Other questions? Okay, I'd like to have your insights on like whether there are aspects linked to specific social context or norms where your gamified approach allows for better engagement compared to traditional methods. Like, do you have some insights on specific social norms or context where your approach worked better?
I believe overall, what I do at ASU and Embodied Games Lab is we build STEM education. And from what I can say from our previous games, is that the more embodiment, the more information you retain, the more that it makes it meaningful. I would say that with this desktop game, it wasn't as much embodied. So I would say that we would probably see different learning games, especially like those who learned more in the tradition. I would expect to see learning games again across all developmental if there was more embodiment. Embodiment meaning that maybe there was a webcam and it was essentially like kill a mosquito, or like they'd be able to point out stuff like on the screen. More embodiment, yes, would help with the learning gains. But this desktop didn't have much. There wasn't any haptics. There was sound, but that was to like the extent of it.
Thank you. Are there other questions for Chloe? Okay, let's thank Chloe for the wonderful presentation. Thank you so much for your time. And let's transition to our second speaker, Dr. Laura Backus. Dr. Lara Backus is an assistant professor at Cal Poly in San Luis Obispo, California. Her position is a mix of undergraduate education and research. So when she received the curricular enhancement grant, she had an excellent opportunity to increase access to public health entomology and vector surveillance for students. Her lab research surrounds tick-borne diseases of human and veterinary importance and is a platform for students to gain some relevant skills. However, through the course, a large number of students were able to gain much broader hands-on skills related to surveillance and management of ticks, mosquitoes, and their pathogens. Over to you, Laura. Thank you.
Great, thank you so much. Let me get my screen shared here. I'm waiting on the plumber, and he should not be here till 1, but hopefully there's no banging on the door while I'm talking. All right, can you see that? All right.
Yes.
Excellent. Yeah, thanks so much for the introduction. I don't know that my presentation is going to be as much fun as Chloe's. I haven't taken this Chloe's game, and I think I might need to go take it now. Might have my students take it as well. But also, as I was imagining college students, I spend a lot of time around college students. As I was thinking about college students playing the game, I was wondering how many said that you should burn the frisbee as the answer for the frisbee full of water in that one. But anyway. So I wanted to talk about, and some of this is going to be similar to what some of you heard me talk about at the PacVec meeting earlier this year. But I was the recipient of one of the PacVec training curricular enhancement grants. And so I just wanted to talk a little bit about the process that I went through in sort of constructing the course that we used that grant for, and some of the lessons that I learned, because now we're done with it. And I was also hoping, I know that we have a lot of people on this call that are educators, learners, or a combination of those two. And so if we have time at the end, maybe we can talk a little bit about ideas and your suggestions for continuing to improve this course. So I am an assistant professor at Cal Poly, and I just wanted to introduce you all to Cal Poly, which is what we call California Polytechnic University. And Cal Poly is part of our 23 university Cal State system. And we are in San Luis Obispo, beautiful San Luis Obispo. And we are in the city of San Luis Obispo, which is in the county of San Luis Obispo. And we are a pretty small county, about 280,000 people and about 47,000 people in the city. And And we are not covered by any vector control district here. In the early 2000s, there was a discussion as West Nile came in, there was a lot of discussion about whether some vector control should be implemented. And politically, the county is pretty divided in half. And so the answer was repeatedly no. So we're not covered by vector control. That said, our public health district has an interest in vectors. Don't feel unsupported that way, but we are not under a vector control district. And we are a master's, like all the CSUs, we are a master's granting institution, and we are primarily undergraduates, about 22,000 undergraduates and only about 800 graduate students. So my role here at Cal Poly, so I am in animal science. And I started here in fall 2023. I came from Davis. I think that most of you already know me, know that I am a child of PacVec. And so I came here in fall 2023 into a position that within animal science, but that was really meant to surround the idea of One Health. Really intended to expand our One Health curricular offerings and provide more structured interdisciplinary opportunities for students. And so I was really excited to apply and then get the PacVec Curricular Enhancement Grant. Was granted it in 2024, and then we instituted the class in early 2025. This was a really fantastic opportunity for me to introduce a class in a way that would have been really difficult for me to do otherwise. So I come from a vector surveillance background and vector-borne disease background. But I came into animal science. And as a new faculty member in animal science, it is potentially hard to say, I want to add on this class to my teaching load, or potentially take something else away from my teaching load in order to teach this class that is not part of our core curriculum. And it gave me a way to say, this is a class and a subject that I think this is really important. Look, they gave us money for it, so it's not going to cost our department anything. And we can do this. So I was really excited about that. It also funded resources that otherwise would have been hard to get. Supplies and equipment, we were able to purchase a bunch of microscopes, including a microscope that we could connect to the computer, which I'll show you in a little bit, which really, really helped with teaching. More microscopes so we could have more students in the lab working simultaneously, as well as student opportunities and field trips. I think it was a really powerful, getting this grant was a really powerful message to the department and the college and the university as a whole, that this is an important subject that we can really be teaching students about, and that is a valuable skill, valuable set of skills for students to be obtaining. And I think that it's maybe seems a little bit strange for me to be in animal science, either from your perspective or from their perspective, to be animal science, really sort of trying to promote a public health entomology focused course. But the reality is that at a primarily undergraduate institution, public health entomology is never going to belong in a single department. We're not going to have a big entomology department or anything like that. And so I think coming at it from animal science is actually not a bad idea or a problem at all. So as I started thinking about both proposing this course and then once we had the grant, really implementing it, what we ended up doing is creating a special topics class. Special topics classes are, for us, classes that you can propose on relatively short timeline, which is really helpful. You just have to do it a quarter or two in advance. They don't have to go through full curricular review or anything like that, which is critical for getting this implemented quickly. And so the way that I did it this time was to have a 1-credit lecture in our winter quarter. We're on quarters for the moment. And then students, the same set of students that took it in winter quarter, needed to promise that they would also take our lab in spring quarter. We targeted it to enroll 16 to 20 students, and there was an application required. And it was not a heavy-duty, in-depth application. It asked basically, why did they want to take the course? It summarized what was going to be included in the course and asked them to acknowledge that they wanted to learn those things that were going to be included in the course. And also made them, there's no way to force students really to take a class that occurs over 2 quarters to make them take the second quarter, but they did have to agree that they would take that second quarter. They would take the lab class in the second quarter. The application was not GPA based. We didn't ask for GPA or anything like that. And it was not seniority based. So students from any year were able to, freshmen through seniors were able to apply. So in the end, we ended up with 18 students in the course. They were a mix of first through fourth years. The majority of them were coming from animal science, which their credits were coming from animal science, and so that makes sense, and more students in animal science know who I am. But we did advertise it throughout sort of all of the sciences, all of the departments that were willing to post it, which many were. But we also had students from biology, microbiology, and business, actually, which was really interesting. And so these are my students behind our not super attractive gold cow. That is our hallmark. They were a really fantastic group of students. So this first quarter, which was really centered around didactic learning in the classroom, it was winter quarter, maybe weather wasn't going to be that great. And so most of it was lecture based, although not all of it. We started off with a knowledge base quiz where students showed that they had a really, really wide diversity of knowledge coming in about vectors and vector-borne diseases. Some of them could identify what a vector is. Some of them had no idea what a vector is. Some of them could name maybe one vector-borne disease. Some had a pretty good suite of vector-borne diseases at their disposal. But the class was, as a whole, centered around a background to ticks, mosquitoes, also fleas. We did a little bit of fleas, and the diseases that they carry. We also talked about field techniques for vector collections, and spent a little bit of time going out just around campus, doing a little bit of training, learning how to do those vector collections. We also had guest speakers on careers in vectors and outreach, and they had weekly assignments to supplement the lecture as well. And I will say that actually one of the really successful assignments that they had to do relating to Chloe's talk about gamification was we did a mosquito breeding site scavenger hunt. And whoever identified the most sites, and also if they identified larvae in the water, they got prizes. So that was a really, really fun one and a really great way to get them sort of engaging with mostly campus. They did mostly around campus in their homes and things like that. But I think that that really helped them sort of prime their vision for looking for those kinds of things. So in the second quarter of the course, we had our laboratory portion. This was in the spring when fortunately the weather was good. And what ended up happening schedule-wise is that we divided the class into two lab groups. So this is a mistake. I don't know, a challenge that I encountered is that when you ask students to participate in two sequential quarters and not knowing what their schedule is going to be like in the spring, there was so much conflict that then we ended up needing to do two lab groups. So two groups of 9, which was really great for working. 9 is a great number to work with in the lab and for teaching and things like that. But schedule wise, it was kind of rough. They were divided into teams of 4 or 5. And over the course of the quarter, they had to design 2 separate surveillance plans. And they had a lot of latitude in these surveillance plans that they developed. But they had to do ticks in the first half of the quarter and mosquitoes in the second half of the quarter. So they were also given extremely broad latitude as to where they deployed their surveillance plans. They needed to identify specific issues that they wanted to address for each plan, like sort of what question their plan was going to work on answering. And then wherever they thought that plan was best to implement, they could do that. And so we had materials available for them for ticks to do flagging and dragging, and they could elect to do dry ice traps if they wanted to as well. Nobody did dry ice traps, but so all of them ended up doing flagging and dragging for their surveillance plans. And then also provided CDC light traps with dry ice, overcups, larval dipping for mosquitoes. They had the option of using any or all of those for those plans. Some used only one, some used a combination. So they would then take the ticks or mosquitoes that they collected and bring them back to the lab and identify them, and then summarize them, count them, put them on a map, and make a report about it. And their final project at the end was to create a written report, which they then needed to present sort of in the style of like our state vector-borne disease, CDPH vector-borne disease report. So each ticks were 4 weeks, and then mosquitoes were 4 weeks. And then each week we would meet and they would talk about what they had done the previous week, what had worked, what had not worked, and we would talk about kind of updating that plan as we went. We're really, really fortunate. Those of you who know me know that I am not really a mosquito person. I am kind of a tick person. And so it was really, really fortunate that we had Kaylee Kwan, who is a senior student this past year in biology, who she actually had completed a summer internship at Santa Clara Mosquito and Vector and was well versed in mosquito identification. And she also helped a lot in our lab as well. So I was really, really happy to have her along. One of the really big challenges that I encountered, and I think that this is a challenge that many of us encounter, is trying to teach ID in a relatively short period of time. In a way that is appropriate for what they need and the skills they need, and is also correct and scientifically appropriate to do. Because I really wanted students to come out of this with an understanding of how to use a dichotomous key, an understanding of how we sit down. We don't just flip through the book and be like, yeah, it looks like that one, it looks like that one, to really identifying structures and sort of learning a little bit of anatomy. There's also not a huge amount of time to do that. And it is hard to find resources that are amenable to being used in those kinds of lab situations. I think those sort of learning lab situations. And so what I ended up doing is creating these packets of sort of customized reference materials where we took materials from a bunch of different sources. We used Ticks of California because it's a classic. Also a hard way to identify an ichthyes, but it's a classic. We use the Guide to Derma Centers. We use the Illustrated Guide to Mosquito Identification, which I think that comes from, or the Mosquito Genera Identification Key, which I think comes from, let's see, it's APHC. And then really fortunately at PacVec, I found out about this amazing guide out of Shasta. From Shasta Mosquito Vector Control. They shared their illustrated guide to mosquito ID with us, which was really, really great and super helpful. It really enabled students, first of all, being sort of California focused was really, really helpful. The mosquito genera key, it's hard because that's like the entire country. And so it was really nice to have that California focus with really, really nice pictures. So that was really helpful to us in the lab. And the other, for ticks, the other thing that we used is Tara Roth, who many of you know has been working on producing education-focused tick ID materials. And she let us sort of trial some of those, which was really, really helpful for our tick ID in the lab as well. But it was really kind of like a mishmash of things. Students have these packets of old-fashioned typewriter type and modern pictures and all these different things. And I think in the end it worked fairly well, but there is a little bit of this element of, well, why am I using this for this? And the answer is sort of because I told you, which is not my favorite way to teach. So it was a challenge. We made it through, continuing to look for better resources, and I would love to hear if any of you have suggestions. For things to use or experiences, things that have worked for you, things that have worked for you in teaching or learning. One of the things that was really, really fantastic, and I'm so excited that we were able to do through this grant, is we were able to get a nice microscope that we could connect a camera to and put on the computer, display on a computer screen. And because we mostly just did it on our small computer screen because we had a fairly small group most of the time in lab. But for learning ID, it was so much easier to be able to say, oh, bring what you're looking at over here, put it under the microscope, and then let's look at it together on the computer screen and let's decide if we're looking at the same thing or not. Because it's really hard if you're just trying to look on either side of a microscope and they're like, well, it's that thing, that pointy thing with the shape and the brown. And this was way better and way easier. And I've continued using this and will continue using it. So I will not go in depth into the results of our student surveillance programs, but I will tell you that they were wildly mixed, which was an interesting lesson for me. Really, really different results. Students, depending on how they had decided to deploy their plans, and also how they interpreted instructions. Really, really learned a lot about giving instructions, and I think I will give, I don't know, you realize that you're making assumptions when you write assignments and give directions. And sometimes you recognize that you made assumptions that you should not have made when the student work comes back. For ticks, so remember, they did this surveillance project over 4 weeks, going out multiple times a week. There were 4 to 5 people per team. They range from 40 ticks collected to 1,074 ticks collected per team. So the team that only collected 40 had a hard time in the lab because they were getting kind of bored, but they helped our team that had 1,074 ticks, primarily Ixodes pacificus and Dermacentor occidentalis because the time of year it was. Mosquitoes, they had much greater diversity, lots of different species, many that I don't know that much about, which was cool. We got to learn more about them. Many fewer individuals. I think we have some work to do in terms of targeting our mosquito surveillance, both in time and space. The majority were probably our Culex quincafasciatus. Also got some super interesting Anopheles and Culicida things that for me were very cool because I don't spend that much time looking at mosquitoes. We also got to go on some field trips and get out a little bit, which was really, really cool. I think that maybe Karen is on this call. I think Karen, I saw you here a little bit ago, but Santa Barbara, Mosquito and Vector, were really, really kind and let us go out with them. They come up to Oceano, which is in our county. And they have a contract there, so they come and do some surveillance, some mosquito control. And so they gave up their morning, mostly gave up their morning. I think we took the better part of their morning, showing us around, showing mosquitoes, showing students how to dip for mosquitoes, and talking about the work that they do. So that was really fantastic. And the students loved it. Not everybody was able to go. Scheduling for that was hard. But the students that went were really, really excited about it. And they commented on how great that was in their follow-up surveys. So I also got to bring 4 students to PacVec, which again was really impactful for those 4 students that got to go to PacVec. They talked about it basically for the entire rest of the quarter, and talked about the things they had heard and brought those back to class, brought what they had learned back to class and the lab, which was really cool. We also went out and did some burrow swabbing for fleas as well. At the end, so we got student feedback over sort of at the end of spring quarter, covering both quarters. And it really, really was very, very positive, which I think was very encouraging. It's always hard to know when you're in the middle of a class whether or not it's going as well as you hope it is. But student feedback was really, really positive. One student said I would take this class 10 times over if I were able to. And the feedback also indicated for the most part that the students really got out what I was hoping that they would get out from the class. I really enjoyed how hands-on and teamwork this class, I think teamwork focused this class was. I also enjoyed how open it was for students to design their own projects. And students really, really enjoyed the guest speakers as well. Every time we had a speaker, I got more and more interested in this field, which is really, really what we're hoping will happen. So that was great. Suggestions that came from participants for improvement for next time. The biggest suggestion, which the majority of students said actually, is that we need more time for lecture and lab. So more time, more units allocated both for the lecture and the lab portion. And they also said they wanted more guest lectures and field opportunities, which really goes along with also having more time available to us. The benefits that I was hoping that students would get out of this, which I think they mostly did, are skill development, vector ID, sort of the hands-on technical aspect of vector ID and surveillance methods that they can go and put on their resume and take forward with them, but also really problem solving. We really focused a lot on problem solving, like how do you think critically about vector-borne issues and how do you come up with a plan to address them? Some really fantastic career exposure because I don't know, none of these students went to college thinking that this was the thing that they would be interested in. And all of them said, yeah, this increased my interest in vectors as a career. And they also did some network building. They now know where to look for jobs related to vectors, have practical experience that they can take to apply to those jobs. And I think on the whole, really sort of developed their interdisciplinary skills as well, regardless of what department they came from. Challenges and lessons that I took away from this. Seasonally, the way it was scheduled was fantastic for ticks. It was not so great for mosquitoes. It was early for mosquitoes. We didn't catch as many mosquitoes as students wanted to. Again, targeting, I think, is a big part of that as well, in terms of where students were going. Time and transportation were issues as well. And certainly, I was kind of hoping, so we don't have vector surveillance in our county as a whole. But I really thought that it would be great if we could sort of get out a little bit and give some information to the county, share some information with Marco and Sarah. But students really, I mean, they're really, really busy and they don't all have transportation. And so their surveillance efforts really needed to be fairly close to home. And so that really kind of centered around campus and around town where they lived. And so I think I don't think that's necessarily a problem, but I think that it will change how I approach this in a little bit in the future. Scheduling a multi-quarter class was really hard. Teams also had a hard time, and so we're solving that in the future. I'll talk about it in a second. And teams also struggled a little bit to schedule with each other. So again, we had students coming from different majors, first year through fourth year, different work schedules, different class schedules. They didn't all have to go do all of their activities together necessarily, but there did need to be a certain amount of coordination for them to execute their plans. And that was really hard for some people. And I don't know exactly what the workaround for that is. But I think more communication early on, I think, is going to need to happen. Field trips were also really hard to schedule. Again, my time, I teach most days of the week. Students have classes and exams and things that they can't miss most days of the week. So that does make those sort of getting out a little bit harder, and making that happen more often harder. So I mentioned this, but basically realized that I had left some details when I gave them instructions, saw that reflected back to me when they brought their results back. We talked about resources for vector identification being something that I think we can work on improving as well. One thing that I realized, and I did not realize this super early, was that many students were kind of missing a framework for analyzing their data. And we weren't doing any complex stats or anything like that, but how to analyze and present their data and how to present even just very basic numerical data in a way that makes an impact and is comprehensible and useful to the reader. That was not a deficit that I had realized was going to be there. And so I would absolutely and will in the future dedicate time to talking about how we do that and tips for doing that. But on the whole, in the end, the students produced some fantastic projects. Some of them were really, really beautiful. I don't know if any of you need to hire anyone for making your annual reports, you might want to talk to them. So coming up in 2026, we are going to do this again this year, which is really fantastic. I'm so excited that my department is willing to support me in doing that. We are going to do it in a single quarter, though. We don't have the opportunity to increase our number of hours substantially because the way my teaching load is right now, and with the course proposal, but we're going to have 1 hour of lecture and 3 hours of lab a week, all in spring quarter. And I think because of the way we're doing it, we'll be able to do more guided field activities. Students are still going to implement their own projects, but we will have the opportunity to go out as a group, hopefully target some areas that maybe otherwise we wouldn't be able to do any surveillance, and work together a little bit that way. I would love if there were ways to extend our mosquito surveillance into summer a little bit. I don't have any great solutions for that right now, but I think in terms of getting valuable information that maybe has public health value, I think that would be very cool to do. So I'm thinking about that. Challenges that are coming. So we were not able to significantly increase the amount of time for this course that is coming. And then we are doing a transition to semesters in 2026, so we will not be able to, we can't propose any new courses because of that. So there's going to be a little bit of a pause there. But then I am hoping that once we've made that semester transition, we can introduce this as like a 2 lecture, 2 lab a week course, sort of experiential field course for students that I think will be really exciting and really valuable. It also, I mean, this is a hard year to be trying to sell students on jobs in the government and jobs in public service. So that was a little bit tough. But I think hopefully by sticking with it and by the time they graduate, we will be in a better spot there. So thank you so much to PacVec for funding this. This would not have happened without the grant. And I also really want to thank everybody who gave our students opportunities, came in and did our career panel, did career talks. Really fantastic. So thank you so much to Santa Barbara for their support, especially. Really appreciate all of your help and also helping develop the course as well. So, all right. Happy to take questions now. And also, if anybody has suggestions, ideas, tools you used for teaching, what tools help you learn, I'm happy to hear about those too. I will stop sharing.
Thank you, Laura, for the wonderful presentation. We have a question from Jessica Coolidge. How much interest did the students show in the course prior to the start of the class? Did you get more applications than you had spots available?
We had a couple more. So we did not have an overwhelming number of applications that meant we had to turn students away. I think the only students that we turned away actually was because their schedule, we had a conversation about their schedules and it wasn't really going to work with their schedules. But now I think it becomes sort of this self-propagating thing where once students know about a class and then they talk to other people about the class, and there has been a lot of positive buzz about it. I'm anticipating more this year, probably.
Great. We have another question from Sonja Savik. A great presentation. Are there any other entomology courses that students could take after this course if they wanted to continue to pursue these topics?
Yeah, so that's a really good question. The answer is sort of. They're in the bio department. There is an entomology, there are entomology, medical entomology courses in the bio department. Those are hard for students to get in because they often don't have the prereqs. And actually, the person who is teaching those is retiring. And so I'm not sure what is going to happen with that in the next couple of years. What I think mostly happens is students then ask if they can come join my lab, has been what has largely happened. But I think it would be very cool to have more classes surrounding this and surrounding sort of the animal health overlap and things like that.
Thank you. Other questions?
I might just chime in really quick. Hey, Laura, how's it going?
Oh, hey, Stephen. Hi, how are you?
Good. I just had a quick observation when you were talking about like scheduling and getting out into the field and then how close your samples are for sites and stuff like that. I think it's a great observation and a great experience for students and stuff like that, because when you do schedule or you pick your sample sites, you really got to be careful about how far you're going, because it all comes down to budgets and timing. We had a surveillance program running this summer, and we were running up from Vancouver all the way to Pemberton, which is about 300 kilometers. And the students were really, let's go do this. And then I was like, this is a long day. Like, you're looking at more than 8 hours, and majority of that will be driving. Like, I know you're super excited to do all these locations, but we're gonna have to scale it back, and we ended up having to do that. So I think experience-wise, I think you've pointed something out. I just thought it would say, like, it is great experience knowing that you do have long days. It's not always the best to go as long as you can. And budgets do cut into mileage and all that kind of fun stuff. So I think it's a teachable moment is what I'm going for.
I think it's true, but it's also a lesson that I keep not learning over and over too. So
we're just so excited. That's all it is. I understand.
Chris?
Yeah, Chris.
Hey, Laura, a great presentation and great program there. I'm really curious how you decide which vectors to prioritize, and I'm interested in San Luis Obispo because you've got some interesting intersections of ecologies there. And one of my most memorable early California experiences over 20 years ago was going out with Bill Risen in Morro Bay. And at the time, he was just trying to get some dorsalis from salt marshes, but he watched the tide tables and timed it perfectly. And we went out and got larvae from there for a vector competence study. And I'm wondering, that's very close by, but are you looking at those kinds of ecological contrasts, or are you trying to focus on public health relevant vectors for the most part?
So we were very much focused for what we did this last time. We were very much focused on public health relevance. Think that the ecology aspect of it is really exciting, and I think that talking about what classes would come later, I think that that would be a fantastic one. I mean, and I certainly like when I first dreamed it up, it was huge, right? And then we sort of had to scale down to what was practical. And so no, we went very heavy on like sort of what are our major diseases of concern. And again, not knowing where we were going to be first years through fourth years, really trying to make it super, super accessible that way. But we do, and that's actually one thing that I would be really, as they do their projects, I would really like to come up with a situation where we can kind of compare what students found in different areas. And I think that that would be a really great one.
It's really great work.
Thanks. Thanks for your support.
Thank you, Chris. We'll probably wrap up with one quick question from Olivia Winokur.
I took my hand down because I realized it wasn't going to be a quick question, but
That's okay. Go
it's
ahead.
less a question for Laura and more just a general thought. But it'd be really cool to hear from like the vector control folks on the call, and maybe this is for a future time, but like what things you think would be also helpful to prioritize in these kinds of courses. I'm just speaking from my own, teaching as well. And I kind of was aimless, so maybe we could just end there.
I think that's a great question, though. And actually, I have the same question. And so I that is a question that I have been posing to people, and I would very much like to continue hearing what skills, yes, people want to see students coming out with. So I think that'd be great. But we can also, if people need to go, that's totally fine. It's 1 o'clock.
It's past 1, and with that, we'll thank Dr. Lara and Chloe for their wonderful presentations and for everyone for joining us. Thank you.